Okay, so hello. Today we are going to discuss design, add, and search word data structure problem. So in this particular problem, we have three APIs. First one is word dictionary. So in word dictionary, you have to initialize your object, right? Or you can say it's a constructor. In the second API, which is add word, you have to add the word in your data structure, whichever you are initializing during the initialization of the object. And in the third one, search word, you have to search and tell if that word is present in your data structure or not. So these three APIs you have to implement. So this is the example. So here in this particular case, you will just initialize your object, then add word will be there. Add word is bad, so you have to add bad in your data structure. Then you have to add dad and then mad. And when so these three things are added, add, dad, mad. And whenever I will search for something, for example, here I'm searching for pad. Pad is not present here, right? So you have to return false. And bad is present, so you have to return true. But the one caveat which is here, that dot can also be there in the search queries. For example, if I'm searching for dot add, then this dot can be matched with any character. Any means A to Z, any character. So it will match with bad also, dad also, mad also. So it will return true, right? Here b dot dot, same, b dot dot, these two can match with any character, so it will match with bad and it will return true, right? So this is the problem which you have to solve. There are two different approaches. One is hash map, which is not optimized one. Second one is try, so which I'm going to explain right now. So in try, what you will do, you will create this particular data structure. So what is try? In try, generally you have nodes, right? So in some particular node, if you will say this is a try node, right? So what you will do, you will have 36 character array here in this try node. 36, not 36, 26, sorry. Okay, so 26 character array in this try node, and initially everyone is storing null only. So uh, only null I'm representing by this, right? So everyone is storing null. But when you will add something, let's say this is the head of the try node, try, or root, whatever you want to say, head or root. Okay, I'm saying head. This is the head of the try. So if you want to add bad in this, so what you will do, you will go to the, because this is 26 length, so you will go to the second node. You will see if it is null or not. If it is null, then create a new node, same as this one, try node. Again, here 26 character array will be there. Create a new node and add its address to this particular location, right? So same thing you will do for every node. And again, so for example, I'm adding bad, so I added in the second location this particular, then I will search for A is again null here, so I will create one more node and add it, then go for D, right? So D here also, this is null, so add it and save the address here. And when I will just, means whenever string is completed, means done, we are done. So we are actually storing one more thing with every try node, which is end of word, right? So in this particular first node, end of word is false because nothing is ending here. Same for here, same for here. But in this particular location, end of word is true. Why? Why? Because we are ending this particular bad word here. The same thing we will do when we will add dad, mad, or anything. Okay, so we will add everything with this simplicity. And when we will search is a little bit tricky here. So when we will search for pad where there is no dot, it's simple. You will do the same thing which you are doing in add, similar thing. If P is not null, then you will go inside that. If again check, if A is not null, then go inside that. D check, go inside that. And if end of the word is true, then return true, otherwise false, right? And if any of the thing in between that path is null, return false. That's simple. But when there are dots like this, what you will do? So if there is a dot, you have to consider each particular case. For first, in this case, first is dot. So you will search in this complete array, if any of the character is null, you have to consider that particular case. And to consider that particular case, I am actually creating one queue so that it will become easy. So what I'm storing in queue, so this is a queue I created, right? This is a queue I created. And what I'm doing, level wise, I am traversing it. Okay. So I picked this one. If this is dot, I checked every particular character here, whatever is null, and added all the things in the queue. So for example, B is not null. Then like this, again, this particular D is not null. So D I will add, means it's actually tree node. It's tree node I will add, right? This is the array of tree node. So which that thing I will add here, tree node of B I will add here. Okay. The same thing I will do for others. So this node is done. This dot is done. All the combination are added in the queue. Now next dot is coming. I will pick this particular B from here. Means I will poll this particular B. And then, so this particular node will come and then check same thing, everyone which is null here, and add it to the queue again. So this is next level I'm traversing. Same thing I will do for D, E, E. So next table will be ready, right? If you have solved the problem of BFS, label by BFS, then it's similar kind of problem, right? So you will do like this, and then this particular thing is done. Then again, D is not dot, right? So you have to just complete this label, and wherever D is present means, so after second label, you will again have some queue with some of the elements, right, added. And if D is coming, pull everything out and check wherever D is there, then push again. And in the last, if queue is not empty, means you have something, you are in the end, then check if any. So in the last, you will have some of the elements in the queue, right? And your search string is ended. So what you will do in this queue, whatever element is there, means whatever tree nodes are there, check if any of the node has end word is equal to true. If any of the node has end word is equal to true, you will return true, otherwise false. This is the solution. Okay, I will explain in the code for like further explanation. I know this is a tricky one, that's why I'm explaining code also. Otherwise, generally I don't. I ask you guys to solve yourself, right? So how we can see this particular code? So this is the try node, right? In the try node, I have end word stored. I have 26 children stored. I initialize them. All the children null initially, and word false initially. This is the try node which I'm creating. This is the initialization for word dictionary. So try initialize, head initialize here. And this is the add word. So if what I'm doing in the add word, I have current is equal to head. So if our current dot child C means that means character by character I'm going. So if the first character I'm picking 0 index character, if that has equal to null in our, for example, this is the head, right? And our first character, if our word is bad, B is there. So in the head, I will check if the second location is null or not. If it is null, add something in this, means create a new node and add it here. And then then now this is our current one. So changing the current one and doing the same thing. In the last, I'm adding current dot end word equal to true. So this is the end code, means add word code, sorry. And now we have to look for the code of search, which is little tricky. So in this particular code, what I am doing, I created a queue and added the head, means current is initialized with the head, and added that in the queue. And what I'm doing, I'm going character by character. Like for example, if you have to search bad in this or dot dot D in this, so first character I'm picking, I is equal to 0, going inside, checking size of queue size because I want to do label traversal. So this is one of the method what you can do. Whatever you are adding in the first level, check the size, right? And start the for loop for this size so that you will traverse this only in this particular level, and add the childs of it in the next, and iterate this thing in the next level. So this you can implement. So size I'm calculating, and for that I'm creating one loop, and current node is q.poll, and I'm checking if word.character at I is equal to dot, then in this case I have to consider everyone and add it to the queue, which is not null. And else if it's not dot, then simple c, the character value will be this one, integer character integer value, and then check if it's not null, then add into queue, otherwise leave it. And the last, I will check whatever is there in the queue. I will check if any of the tree node has this end word is equal to true or not. If it is, then return true, otherwise false. So this is a code. And thank you for watching the video. If you have any doubt, please ask. I will definitely try to reply. Thank you so much.